Why is testing necessary? Rigorous testing of components and systems, and their associated documentation, can help reduce the risk of failures occurring during operation. When defects are detected, and subsequently fixed, this contributes to the quality of the components or systems. In addition, software testing may also be required to meet contractual or legal requirements or industry-specific standards. Testing is a crucial step in the software development process that helps ensure the quality and reliability of a product. It helps identify defects, bugs, and errors in the software and helps ensure that it is fit for use. Testing also helps validate that the software meets the requirements and specifications set out by the client or end user. There are several reasons why testing is necessary. To ensure that the software is of high quality, testing helps identify and fix defects and errors in the software, ensuring that it is of high quality and fit for use. To ensure that the software meets requirements, testing helps validate that the software meets the requirements and specifications set out by the client or end user. This helps ensure that the software is fit for its intended purpose and meets the needs of the user. To identify and fix defects before deployment, testing helps identify and fix defects and errors before the software is deployed, which can save time, money, and resources. To reduce the risk of failure, testing helps reduce the risk of failure by identifying and fixing defects and errors before the software is deployed. This helps ensure that the software is reliable and fit for use. To improve user satisfaction, testing helps ensure that the software is of high quality and meets the needs of the user, which can improve user satisfaction. Testing's contributions to success. Throughout the history of computing, it is quite common for software and systems to be delivered into operation and, due to the presence of defects, to subsequently cause failures or otherwise not meet the stakeholders' needs. However, using appropriate test techniques can reduce the frequency of such problematic deliveries, when those techniques are applied with the appropriate level of test expertise, in the appropriate test levels, and at the appropriate points in the software development lifecycle. Examples include: 1. Having testers involved in requirements reviews or user story refinement could detect defects in these work products. 1. The identification and removal of requirements defects reduces the risk of incorrect or untestable features being developed. 2. Having testers work closely with system designers while the system is being designed can increase each party's understanding of the design and how to test it. 2. This increased understanding can reduce the risk of fundamental design defects and enable tests to be identified at an early stage. 3. Having testers work closely with developers while the code is under development can increase each party's understanding of the code and how to test it. 3. This increased understanding can reduce the risk of defects within the code and the tests. In addition to these examples, the achievement of defined test objectives contributes to overall software development and maintenance success. Quality assurance and testing. While people often use the phrase quality assurance, or just QA, to refer to testing, quality assurance and testing are not the same, but they are related. A larger concept, quality management, ties them together. Quality management includes all activities that direct and control an organization with regard to quality. Among other activities, quality management includes both quality assurance and quality control. Quality assurance is typically focused on adherence to proper processes, in order to provide confidence that the appropriate levels of quality will be achieved. When processes are carried out properly, the work products created by those processes are generally of higher quality, which contributes to defect prevention. In addition, the use of root cause analysis to detect and remove the causes of defects, along with the proper application of the findings of retrospective meetings to improve processes, are important for effective quality assurance. Quality control involves various activities, including test activities, that support the achievement of appropriate levels of quality. Test activities are part of the overall software development or maintenance process. Since quality assurance is concerned with the proper execution of the entire process, quality assurance supports proper testing. Testing contributes to the achievement of quality in a variety of ways. Errors, defects, and failures. A person can make an error, mistake, which can lead to the introduction of a defect, fault or bug, in the software code or in some other related work product. An error that leads to the introduction of a defect in one work product can trigger an error that leads to the introduction of a defect in a related work product. For example, a requirements elicitation error can lead to a requirements defect, which then results in a programming error that leads to a defect in the code. If a defect in the code is executed, this may cause a failure, but not necessarily in all circumstances. For example, some defects require very specific inputs or preconditions to trigger a failure, which may occur rarely or never. Errors may occur for many reasons, such as 1. Time pressure. 2. Human fallibility. 3. Inexperienced or insufficiently skilled project participants. 4. Miscommunication between project participants, including miscommunication about requirements and design. 5. Complexity of the code, design, architecture, the underlying problem to be solved, and/or the technologies used. 6. Misunderstandings about intrasystem and intersystem interfaces, especially when such intrasystem and intersystem interactions are large in number. 7. New, unfamiliar technologies. In addition to failures caused due to defects in the code, failures can also be caused by environmental conditions. For example, radiation, electromagnetic fields, and pollution can cause defects in firmware or influence the execution of software by changing hardware conditions. Not all unexpected test results are failures. False positives may occur due to errors in the way tests were executed, or due to defects in the test data, the test environment, or other testware, or for other reasons. The inverse situation can also occur, where similar errors or defects lead to false negatives. False negatives are tests that do not detect defects that they should have detected. False positives are reported as defects, but aren't actually defects. Defects, root causes and effects. The root causes of defects are the earliest actions or conditions that contributed to creating the defects. Defects can be analyzed to identify their root causes, so as to reduce the occurrence of similar defects in the future. By focusing on the most significant root causes, root cause analysis can lead to process improvements that prevent a significant number of future defects from being introduced. For example, suppose incorrect interest payments, due to a single line of incorrect code, result in customer complaints. The defective code was written for a user story which was ambiguous, due to the product owner's misunderstanding of how to calculate interest. If a large percentage of defects exist in interest calculations, and these defects have their root cause in similar misunderstandings, the product owners could be trained in the topic of interest calculations to reduce such defects in the future. In this example, the customer complaints are effects. The incorrect interest payments are failures. The improper calculation in the code is a defect, and it resulted from the original defect, the ambiguity in the user story. The root cause of the original defect was a lack of knowledge on the part of the product owner, which resulted in the product owner making an error while writing the user story.